Do you have to reinvent the wheel every time you build a robot? Or can you reuse significant components of functionality like vision, navigation, manual dexterity, and control software? It turns out that the answer is yes. And the result of asking that question was the creation of what might be the world's first robot venture factory in, of course, Odense, Denmark, an island with perhaps the world's greatest density of robotic startups and creators.
So my name is Klaus Rüsiger. I'm the CEO at Blue Ocean Robotics, and I've been in the robotics industry for 33 years. So that's
What?
very short, right?
Not short at all. That's a lifer in robotics. That's impressive. That's amazing. Where are you based?
I'm based in Odense in Denmark.
I have been in Denmark, actually, Copenhagen, and then is that the island where there are like literally 25 different robotics companies operating
Yes,
simultaneously?
yeah. So
Amazing.
Copenhagen is on this island called Zealand, and the island just next to that is called Funen, and this is
Yes.
where we are around 150 robot companies, and there's 500,000 people on the island. So
It's amazing. I did a conference there once, and it was incredible. I love to come back sometime. But let's start here. What is a robot venture factory? You say you're the first robot venture factory on the planet. What is that?
So what we have really done is to focusing on how you come from an idea through design development to a market footprint and scaling up in a market. You know that actually thousands of robot companies have this dream of succeeding with the robots, and many of them die. Like there are more than 10,000 robot companies in China, less than 5% are actually doing well. So
Wow.
the challenge of building both a physical product and with all the software and being able to produce and deliver something successful and the customers wants to buy, that seems to be a very hard thing. We've basically industrialized this. So we have now a portfolio of three robots, and we can easily add a fourth and a fifth and so on, because all the technology that we use and all of the business components that we use, these are kind of the same and we can be reused across all the robots. So this is, in our view, a very unique thing.
It is unique. It is super interesting. I want to dive into what that core of technology is and if there's that core of software that can run, 90% of what a robot does. But let's start here. What are your most successful robots to date?
Well, the most successful is the first of our robots that we started with, the UBD robot. It was launched in the market in 2018. Development started in 2014, but it was entering into the market in 2018. And we're basically selling this robot in more than 70 countries today, and it's very successful. And of course, I mean, we had a lot of growth, and then the Corona pandemic came in, and everyone needed a robot to kill the bacteria and virus. I mean,
Yes. Yes. What does that robot do?
on this robot, there are some light bulbs that emit UVC light. That is a special type of UV light with a 254 nanometer wavelength. That light penetrates into the cells of virus and bacteria and destroys it. So by intelligently moving that light around in a hospital room, for example, or in an operating theater, we can kill all the bacteria and viruses. So in a large room, 10 minutes, 99.99% of all bacteria and viruses are gone.
Wow. Wow. Well, that is timing, right? I mean, you have the robot, you have the capability, the disaster strikes, and you're there. Let's talk about what you mentioned off the top in terms of building a robot venture factory. There's so much more to building a robot than identifying one task or one niche. There's a core of software, there's sensing software, right? Where am I? What's around me?
Yeah.
How do I move? How do I not bump into things? How do I engage with my environment? How much of the software stack for your robots is kind of the same, and how much is unique given the special tasks it has?
I would say maybe something like 70% is generic, 30% is very specialized. That's just a rough number. But all the software that relates to, for example, the normal type of navigation, and as you say, avoiding colliding with the environment, the human robot interaction, motor control systems, all of that is kind of the same. But then there needs to be special made software as well. For example, if you take the UVD robot again, it moves into a room. You want this light to get close to different surfaces, hotspot surfaces where you know the bacteria are growing. You want to get close, but you don't want to collide. At the same time, you want to expose that surface with the right amount of light to kill all the bacteria, but you don't want to overexpose because then you destroy materials. So here you have kind of, you can see you need a very intelligent system that can balance these. It's kind of a trade-off that you have to do, move in right amount of light, but not too much, avoid colliding, but still getting close in order to be efficient, and then get that done throughout an entire operating theater, maybe with 8 rooms, and do all of that in one row of process. That is quite a task.
Absolutely, I can imagine that. What are some of the robots that you're working on next? Do you have anything that you're cooking up that you're about to release?
Yes, so we have 2 robots. One of them was just launched a few months ago. It's called Gobi Robots. It's a telepresence robot. It means that, like you and I, we are having a dialogue here over the video link. But actually, if I had the Gobi robot with you, I could not just talk to you, but I could also move around. So if you
Yes.
and I were working together on a project, or we were doing something in production, or if you were a doctor and you had patients and you wanted me to assist you in diagnosing and talking to the patients, I could actually move around in your environment and we could do things together. So that robot was launched a few months ago. And it's not just a robot that I can operate, it's also a platform. So you can make software apps and you can upload that to the robot, and the robot can then do things autonomously. So, for example, doing inspections. If you want your robot to move around in your production, counting certain things or checking if certain things are on the floor or if there are people in the environment, you can just ask the robot to do that. So it's more than telepresence, it's the next generation of this kind of interaction together.
That is really interesting. I used a telepresence robot. I live near Vancouver, Canada, and I was writing for Venture Beat probably a decade ago. And
Right.
we got a telepresence robot, and I could start it up in the office in San Francisco and then move around. My face was on the screen there, and it would kind of creep people out, but they got used to it and they started liking
Yeah.
it. This is really neat because you have that aspect, but also the autonomous aspect where, hey, check out what's going on the floor. What inventory do we have? Very interesting. Now, your company name is Blue Ocean Robotics. That brings to mind the book Blue Ocean, Red Oceans, right? Red Ocean's too much competition. Blue Ocean, hey, it's a fresh, it's a virgin area to
Yeah.
explore and build new solutions. What are the parts of the economy that you see need robots the most?
Yeah, so you're absolutely right. That's why we gave it the name. That's because of the blue ocean strategy. We wanted to make robots that go into new market areas where you don't see robots today. So that was the mission of the company and still is. Well, we focus a lot on these large market verticals where you have a lot of services provided to people. So professional service industry, especially hospitals or healthcare, construction, agriculture, and hospitality. There is a reason for that. I think 30% of the population work in these areas. So
Mhm.
there's a lot of volume with people there. At the same time, these areas have a very low productivity growth, even
Mm,
negative productivity growth, and they're also local. They're basically not outsourced. You have agriculture in every country. You do construction in every country. You have healthcare in every country, even in every city. So you don't outsource this. And if you have low productivity growth, what happens with the workforce? Because of competition, those that owns these organizations, they have to put more pressure on the people. You have to run
mm,
faster, lift heavier weights, work longer time, and salary, well, we want to squeeze you on your salary every year. So basically, you have people working there. It's a kind of a trap because they have a poor future for them because they cannot really have a career and earn more. And so it's a spiral that goes down, and it's really bad for these people. They also have a lot of work injury, bad for your health, and a lot of people leave these jobs if they can because they really
Hmm.
hate it. Just hard work, but you don't get any real payment, and it's just really bad. But getting the robots in there, it means a big thing for these people because now they have the robots to do the hard work and they can do the smart work of it. In combination, you can become much more productive. And now this is a positive spiral. You can earn more, you can start having a career. It's not unhealthy for you. So this is we want to contribute to transforming these jobs in these very, very large industries that we have all over the world.
I I'm blown away. That's amazing. That's a wonderful vision. I mean, we look at robotics and we look at jobs and we think that the two are in collision, right? And to some
Yeah,
extent that's true, and that will remain true. But to another extent, or to what you're highlighting here, is there's a lot of jobs where people are run ragged, working too hard. Nursing, for instance, having to move patients, and you've got a 200-pound patient that you've got to move somewhere, and you've got a 125-pound nurse that needs to move the person. I
exactly.
mean, really, really challenging things. And guess what? You can't focus on the actual task of caring for people because you're doing the
Exactly.
physical things. Amazing vision. Very, very cool. I
And that's
wanted to,
actually what you mentioned there. That's actually the third robot we have. The PTR robot is safe patient transfer and rehabilitation robot that can get people out of the bed and do rehabilitation. That robot is entering into the market after the summer.
wow.
So you're right. You're spot on there.
Excellent. And there's a lot of need for that robot in old age homes as well, and even people who
Oh yeah,
maybe want to stay in their homes but need more help being independent. I wanted to ask, what's the line between general purpose and specific task robots? Most robots that we see so far, for really obvious reasons, are built for a specific task. Yet we have sort of this science fiction, and maybe it's going to stay fictional, I don't know, vision of a general purpose robot that can do so much stuff in an environment that is designed for a human body, human fingers, human
yeah.
locomotion, right? How do you see that evolving over time?
Yeah. First of all, I completely agree with you that it's more like a dream or a vision that at some point we will have these intelligent robots that are natural to interact with, and they can cook for you, and they can go to the garden, and they can do the shopping. And I mean, that's that's a dream, and I think it's good to have this kind of long-term vision. But you're absolutely also right that those robots that are successful now are those that are built for a single purpose, and they do that job very well. And you can produce it at a cost where it's very affordable for people, and they love their robot because they can help them with things they don't have to do anymore. So that's where we are. But I think the first movement towards more general purpose is something that, I mean, ordinary people don't see it, but you see it in the industry where you can say that the technology is now moving much more into kind of a modularized and a supply chain organized collaboration between companies. So some companies make an autonomous robot platform, others make an arm, and some make a gripper, some make the camera system that can do the perception and understanding of the environment. And then you can kind of put it all together very easily and configure a robot to do a certain task. But it's basically the same building blocks that you're using. So it enables a faster and faster development of new robots for new applications. And some of them also have this ability, for example, a robot platform with an arm can take off its hand and put on another hand for a slightly different task in the environment. So those kind of things are what we see now. And this is a sign of that we are moving towards this. but it will take decades before we start seeing robots where you and I will say, whoa, it can do a number of things for us. That will take a long time.
Yes, I can totally see that, and I can see how your company as well. You're expanding that envelope a little bit because you've got the robot that does telepresence, but also can take inventory and also maybe do a few
Yes.
more things, add a few more tasks, and a little more intelligence and other things, bit by bit by bit by bit. Tell me, what is it about your country and your island that makes it so amazing in terms of robotics? I mean, you said 150 different companies, 250, I'm not sure, on that small island. What is it that is happening there?
First of all, we have been here for a long time, right? We in the 80s, 1980s, we had a large shipyard, one of the largest in Europe, that was placed on our island. And there was a very visionary CEO there, and also at the local university, there was a very, I would say, untraditional professor who really was strong in mathematics and how to work with dynamic systems and stuff like that. But they found each other. They played golf together, and they kind of teamed up and started this dream about why don't we make robots that can weld the ships, because this is really hard work for people. How can you actually make new generations of robots to do this? So that started 35 years ago, 35 or 33 years ago, because I was actually a part of that team at the university by then.
Wow.
And we were like 15 people starting up at that time. And today, I would say many of the companies are owned by us who started up back then. So over the years, we have just been able to, build this, build that, get that started, work together across, and we're not really competitors.
Hmm.
I think in the industrial area, I'm not in the industrial robotics, we're in the service robotics, but in the industrial robotics area, where maybe Odense is the leading city in the world making new, modern, collaborative industrial robots. It's all started with universal robots. They make this robot arm, lightweight, easy to
Hmm.
program, easy to move around. But it started with them and they became quite successful because there was this opening in the market. But suddenly there was a whole ecosystem around them that made grippers and also cognitive systems to understand the environment. And then suddenly we had an autonomous mobile robot platform for the industry that could carry the arm or without the arm carry something else. And I think we have out of the 150, maybe 30 or 40 are related to this area of the new modern collaborative industrial robot. Um,
Hmm.
and so it's kind of everyone is thinking about how can we stand on the shoulders of all the success that we've generated already, and because you get a lunch for free here because all the resellers we have around the world that are selling these robots, if you add another component, you just call all of them and they start selling your product. So it's a snowball effect that I mean everyone is just pushing on the same snowball, and it's just getting bigger and bigger, and that is a good thing.
It's the Silicon Valley of robotics. Very, very
It is.
interesting. Let's talk, and maybe we'll end here about the future of humans and robots. How do you see that progressing, and what do you see needing to change in our economies, in our societies, when robots start approaching a third, a half of the workforce, and they start doing more and more automation as well as robotics, more and more of the manufacturing and the servicing and delivering and other things like that? How does that change our world?
So first of all, I have always been a very strong believer in human robot interaction. I mean, the best robots you can find on the planet are those where you have thought about the user. Put the user in the charge so the robot works for the user and not the other way around. So start finding out what that person is good at, and then make a robot that does all the dull and dangerous stuff for the user. That is very important, and those robots have a great future. Of course, there are certain applications where you don't want the user to be a part of it. I mean, cleaning up in a nuclear plant, you don't want any user there. Going to Mars on a quite dangerous mission, you want the robot to do it by itself. So there are certain applications like that, but in most, for example, in my area, like the professional service robot industry, you really want the user to be at the center of everything, and you want the robot to do the hard work. So as long as this kind of philosophy is followed, I think there's a great future for those kind of robots. And the same goes for the industry, manufacturing industry. You see the same trend that collaborative robots is a really big thing. And the workers are really happy. I mean,
Yes.
you have a great job. You have robots working for you. You instruct them. You do surveillance. You adjust them, and you optimize. And it's just a great job. You go walk around with your coffee cup, and I mean, it's just a great job. If you talk
Excellent.
about what
Excellent.
we need to do in society, that is maybe something a little bit different. I think we talked about it before. When you move robots into an industry, you're not replacing people like that. You're not losing jobs. You're actually creating more jobs. That is what happens. But the jobs are different. So it's kind of transforming the workplace. I mean, there are more and more jobs in the world that increases every day. One of the reasons is technology, and robot is just a part of that. So you
Hmm.
create more jobs, but they are different. So you
Hmm.
need to enable people, I would say, free access or easy access to education to learn about how to work with technologies. So access to education is really important in that aspect. And then when we progress along in the, let's say, a few decades from now, where robots really take up a lot of space in service industries and in the workplace, people will also have to focus much more on their creative side, and not just surveilling the robots and so on, but really focusing more on developing the company further ahead, or being very creative in how can we improve our things. And
Hmm.
this is basically what people are best at. That is really to think about things, see how we should do things differently. And if you can kind of support that from an educational point of view, or in society in general, I think those countries or those regions are really well off.
Excellent. Excellent. And I can't end this interview without asking about the frog on the wall. I mean, what is the frog on the wall? Where's the frog come from?
What do you mean by that? Sorry for that.
Look behind
Oh,
you.
no, the frog, the frog here.
Yes.
That's from an artist in Boston.
Okay.
I
Well, it
bought that
looks
in
great.
Boston, and there's a number.
Oh, multiple frogs. One was hidden.
So
I
I
love
was
them.
on a trip to Boston. I've been there many times, and there was this artist. He makes these in a small version and this large one, and I couldn't resist it. They're so cute that I had to buy two of them. So
And they're not robotic. Not
they're not
yet.
they're just artwork. Yeah.
Excellent. Well, Klaus, thank you so much for your time. I really do appreciate it.
Thank you, John. Thank you.